Hi, this is Paul Bentley from Lizard NDE, and this is video 6 of the LIS inspection and sizing software videos. Okay, we've now got a scan of an unknown plate, a full penetration butt weld. We use the repetitive function to quickly identify an area of interest for us to look at. And then we performed the scan and we actually put these marker points in as just simple strikes across the data. We do have options up here to change the markers to be actually identified, so whether they have keyboard entries to them or whether they're, as you press the keys, whether they count up in multiples. There's lots of options in there for identifying the markers. In this instance, we'll just use just the basic strikes. Okay, so we now go into sizing. Now the data has been turned on its side, and again we can see that we have very flat data until we hit these defect regions, and we can again do as we did before, which is set the baseline first to as close to the 0 as we can reasonably see fit. So let's have a look at that. Now if I click set baseline, you'll see this results page change as it lifts the defect, the full data trace from the absolute or BX to the 0 position, which is essentially what I'm doing here when I set this baseline. If I set it completely incorrectly, you'll see what I mean from down the bottom. So let's move this back up. Set baseline. Okay, now if you remember, we performed the depth calibration using the LK100 plate with the 2mm deep EDM slots, and we generated a constant number of 415. This 415 number is then used in the algorithms in the background of the LIS software to identify the amplitude of signal. So we've set the baseline. We now are going to, we can jump straight forward and actually depth size straight from here. If I just move the start and end cursors and click find peak, the peak will move to the deepest part. So let's do that now. There you go, there's the depth is now read out 3.3 millimeters. Okay, but we don't want to just do the depth, we want to do the length as well. So to perform the length sizing, what we first must do is create an electronic ruler using the markers that we have already input onto the display. To do that, we take the start cursor and line it up over the top of one of the markers that is surrounding the defect region. We then take the end cursor and do the same, this time surrounding on the other side of the defect region. We have now know that the defect is in this portion between these two marker positions. Well, 3 marker positions, I would say. Now we need to set the constants and tell the system how far apart this start and end position is at the moment. So if I click set constants, it asks me again, is the cursor on a 2mm deep defect? Well, no, it's not. This is what we use for setting up the depth information. We don't need to do that because we have already generated our constant from our calibration scan. So we click cancel. Now the cursor, it asks me, are the cursors on a 100mm long defect? Well, yes they are, because 0, 50, 100. If those marker distances were different, we would just go in and change the length reference. So instead of that being 100mm apart, if we, for example, needed it to be here, we would first place the marker, I'm sorry, I'm having trouble with the with a touchpad here rather than using a mouse. Okay, sorry about that. Okay, so in this point I would then change this to 150, set constants, cancel. Now it asks me if is it on the cursor's on 150mm long defect, so cancel with that. We're not going to do that. Move this back to the correct marker. Now we have a length of 100mm between these marker positions, between the start and end. Now it's very easy to just drag that into the start, into a peak or a trough. And if we take the end, now if we're going to start on a trough, we must end on a peak. Now this goes into more detail in the Lizard training course. You are actually looking to always go for start and end of defects from a peak to a trough or a trough to a peak. You cannot size peak to peak or trough to trough. Okay, so here we have our finished sizing display. We have the start and end positions in the correct position, which actually line up with the peak and trough. And we have, sorry, I keep using the touching the touchpad by mistake on the PC. We can also look at the depth for any part along this amplitude just by picking up the peak cursor and moving it along the signal. So as I move it along the signal, you'll see the depth information change on the left hand side. As actually the defect is two very close fatigue cracks that are almost overlapping each other. Okay, so we have there, you can see this clearly picked up the second defect as well. Again, if we wanted to only size this one particular portion, we would move the start and end like so. But we want the full region for this demonstration. Click Find Peak again. Okay, 3.3mm, 28.2. That is sizing of an unknown defect. Again, very, very quick to do. So one last little trick I'll show you is if you right click and do copy all, we can now use Word or WordPad, and we can drop that information straight into a Windows document. If you will see, we have all of where our signals all up here, and this at the bottom here is the information from the notepad. If you remember, I input some text onto the notepad. When you perform the copy all function, it drops the notepad entries into the display. It's a very quick way of making reports. Okay, so we jump straight back to Lizard, and that is how to very quickly size an unknown defect using markers for length information and using the absolute with the previously identified correct constant number as generated by the scan over the LK100 calibration plate. Okay.